Okay, what we're going to talk about today is average rate of change, one of the fundamental aspects of mathematics here, and the baseline for linear functions here. So things to think about, again, we're looking at tables. If we wanted to list these as ordered pairs, right, you list this as 3, 5, or 4, 10, or 5, 20. All right, just to make sure that you understand that you can always write things as ordered pairs, because that's going to be helpful here when we're talking about our average rate of change. All right. So to start off, first we're going to evaluate each of the functions. So this means substitute in 0, 4, 7, 13, and see what we got here. So if I substitute in 0, I've got right there 0, 1. F of 4 is up here. That's going to be the 0.7. And then f of 7 is this point up here, and that's going to give us an output of 10. And then if we go all the way here to 13, we've got this output up here, which is an output of 15. Okay? So now, if you want to find the change in the function, the change in f, this is delta f, of change in the function, over each of the following domains, find this by subtracting and showing the change in the graph, right? So if I look at the change, I've got 7 minus 1 would be 6 is the change, all right? So if I kind of look at what's going on from here to here, then I look at what's going on in the next interval from here to here, okay? And that would be 10 minus 7 would be 3. And then the last one you can see if I've taken is the 15 minus 10. And then I'm going to get 5. And you can see right here going over. And then I'm going up here. Okay. So we're looking at differences here and these changes and the changes in the f. And why can't we simply just compare the changes in f from part B to determine which interval the function is changing the fastest? And you can see that the domains are not the same, meaning that the x's went up. This is a difference of 4 here. This is a difference of 3 here. And this is a difference of 6. So you can see that there's a big difference in the x values, and it's not the same. So you can't really compare all of these intervals, right? Okay. So what we're going to need to do is calculate the average rate of change, and that's the change in the y over the change in the x. Okay. So what we can do here, what's the change in the y's are going to be 6, and then the changes in the x here is 4. So you would write changes in the y would be 6, changes in the x would be 4, right? So we would get 3 over 2. That would simplify to just 3 over 2. And then over here, you've got the change in the y's over the change in the x. Okay, the change in the x is 3, and then the change in the y was also 3. So you can see that has an average rate of change of 1. And then the last one, the change in the y over the change in the x here, right? The change in the y was 5, and then the change in the x was 6. So that's simplified. You can't simplify that any farther. So we would get our average rate of change is 5, 6. Okay, so now if we want to kind of draw these things right here, we can draw, okay, we can draw a line connecting all of these values, and then you can kind of see here that it relates to the slope, and you can see that the largest slope is in the beginning here from 3/2. So there you go. You can see right here that this slope 3/2 is the greatest rate of change, and you can see it's kind of like the steepest slope too. All right. Okay, moving on here. All right. By definition, here is the definition of the average rate of change. I've got the change in f over the change in the x. Okay, again, the rise over the run. Okay, you can also kind of look at it like that, right? So now what we're looking at here is if we have values, like what is the average rate of change from -2 to 3 over here? And what you can see here is we have to find out what the y value is first. So first, I'm going to substitute f of -2 in. So I'll get 5 times -2 plus 7. And I'm also going to substitute 3 in. So f of 3 would be 5 times 3 plus 7. Okay, so now what we're trying to do here is we're trying to find our y values. So you can see here, we're going to get -3 here for the y value. And then f of 3 would be 15 plus 7 is 22. All right, so now the change in the y's over the change in the x's. Okay, so I'm going to do 22 minus -3, and then 3 minus -2. Now notice how I'm using parentheses to substitute in my values here. So now what we're going to get is 25 divided by +5 is 5. So our rate of change there is going to be 5 here. Okay. Now, if we want to look at the rate of change in our other interval, okay, let's try it for the g function. I'm going to use the g function for number 2, and you can see that we're just going to compare these intervals. But right now, I'm just going to show you the g. So if I've got g of 1 and then g of 5, and if you think about it, you can kind of just start by saying 5 minus 1 on the bottom, right? Because remember, we've got the change in the y over the change in the x, okay? So what is the y value? Well, I've got 2 times 1 squared plus 1, and that's going to give us 3 as an output. And then I've got 2 times 5 squared plus 1. 5 squared is 25 times 2 is 50, and then we're going to get 51 here. So then I've got 51 minus 3 on the top here, okay? So what we're going to get here is once we simplify, we would get 48 divided by 4. Simplified would be the number 12, okay? If you wanted to try to calculate both functions over the following intervals, you can, all right? But just for sake of time, I'm just going to do 2 of those, okay? All right? So what we're looking at here on the last one is this: if this table represents a linear function, right? So if we want a change in the y here is 4, right? And then, or sorry, the change in the x, and then this is going to be 6, right? So the change in the y over the change in the x here is going to be +6, right? Because we're going from -5 to +1. Divided by from 1 to 4 is 4, so the rate of change is 3/2 here, okay? So now, if we're trying to figure out, well, how exactly am I going to get to this table here? And what you're going to do here is figure out, well, what's the equation of this line here? Could we find an equation of this line? All right, so I've got y equals 3/2 x plus b. I know the rate of change is 3/2, and let's pick a point to plug in, all right? So y is 1, okay, x is, if y is 1, we're going to use this point right here. If y is 1, x is 5. All right, so I've got 1 equals 15 over 2 plus b, and then I subtract 15 over 2 minus 15 over 2. And we could just use our calculator for that, all right? So if we want to use a calculator, we've got 1 minus 15 over 2, and then I've got -6.5, okay? So I've got -6.5 is my b value. So now I have equation, y equals 3/2 x minus 6.5. And what you can do here is just substitute in points. If I know 11 is my x value, I could substitute it in. If I know 22 is my y value, I could substitute it in. Well, let's go ahead and do that. All right, y equals 3/2 x minus 6.5. Actually, let's do this in the calculator. All right, y equals, if I put this in the calculator, we can say 3/2 x. and then minus 6.5. So now I can kind of just go look at a table here and then look at a table of values. So if I go up to 11 here, I'm going to get 10 as my x value, right? So 10 would work here, right? If I'm going to find out, well, where's y equal 22? And I just go, oh, there it is, when x is 19. So then I'll just put 19 in right here. And then when x is 45, right? Whoops. When x is 45, we're just going to go all the way down to 45 for our output here. And then you're going to get 61 as our y value. Okay? All right, y'all. Hope this helps.